Hello everyone, this is Dr. Sargam and today we'll study about a very important yet a very confusing topic in ophthalmology, that is determining the refractive status of the patient. So, what is refraction? Refraction is the procedure to determine the refractive status of the patient. So, refraction is done both objectively and subjectively. Now, what are the objective methods of determining the refractive status? It includes number one, retinoscopy and autorefractometry. Subjective methods include astigmatic fan test and Jackson cross-cylinder test. So what happens is when a patient comes to us and we see that the patient is not reading 6 by 6 on Snellen's chart, then we measure the refraction of the patient objectively either via the autorefractometer or via retinoscopy. Now, what is autorefractometer? A lot of you must have gone to ophthalmologist once in their lifetime, in which you are made to sit on a stool and you are made to look inside a machine that has either a home or a scenery. And what the doctor does is the doctor captures your image. So that gives you rough, spherical and cylindrical error of the patient. Okay, once you determine the refractive errors objectively, then you go for the subjective refinement of that refractive error. It can be done through either astigmatic fan test or Jackson cross-cylinder test. Now, what is retinoscopy? Retinoscopy is also known by other names such as skioscopy or shadow test. So, retinoscopy is an objective method to determine the error of refraction. Okay, now what is the principle of retinoscopy? It is based on the principle of neutralization, which states that the light reflected from the mirror into the patient's eye, once it reaches the eye, so it will travel in a direction that depends on the refractive status of the patient. Now, what does this mean? This means that the principle of neutralization states that the movement of the red reflex. Now, what is red reflex? It is basically the glow that you are getting from the fundus of the patient. So, this red reflex, the movement of this red reflex, that will depend on whether the patient is emmetropic, myopic or hypermetropic. Now, what is the procedure of retinoscope? So before that, we should look at the types of retinoscopes. This is a plain mirror retinoscope. This is a Priestley Smith mirror retinoscope. Now it has got two mirrors. One is plain, other one is concave. See, most commonly the plain mirror is used. But what are the conditions in which the concave mirror is used? They are either high degree of ametropia, that is high degree of refractive error, or number two, when the media is hazy. So if we look at these two types of mirror retinoscopes, they both need an external source of illumination, right? However, if we look at this image, this is a streak retinoscope and it has a self illuminating source of light inside it. So basically here there is a self inbuilt bulb inside this retinoscope. Okay, so what is the procedure? They say that we take a conventional distance of 1 meters between the examiner and the patient. Okay, suppose I am the examiner, this is the patient. Now what happens is, and I'm holding the retinoscope, either the mirror one or the streak retinoscope. For the mirror retinoscope, we need to have a source of light. So it is very important to know where is the source of light. So this source of light is behind the patient. It will come from front, get reflected from the mirror retinoscope that I am holding, and it will go inside the patient's eye. And depending on this moment of red reflex, we determine the refractive error. Or in streak retinoscope, the patient and the examiner, they both sit at a distance of 1 meter from each other, and then the moment of this reflex is noted, right? Now, what are the different kinds of movement that we can have here? So, either the red reflex will be stationary, that is it will have no movement. So no movement suggests myopia of -1 diopter. If you look here, this is your streak of light, it is filling the whole of the pupil and there is no movement of the red reflex. So that will suggest a myopia of -1 diopter. Another scenario is when I am moving the retinoscope like this and the red reflex is also moving in the same direction. Okay, so what are the cases in which with the movement is seen? With the movement is seen in emetropia, hypermetropia and myopia of less than 1 diopters. The third scenario is, suppose I am moving my retinoscope like this and the movement of red reflex is like this. That is, both movement are in opposite direction. That is what you call as against the movement. So against the movement suggests myopia of more than 1 diopter. Okay, so this is the procedure. Like, you look for the movement of red reflex and then you make the patient wear the trial frame. Then in the trial frame, you keep on adding the this thing, uh, lenses of different powers. Okay, so what is the end point of neutralization? So the end point of neutralization is when there is no movement of red reflex and it completely fills the pupil. Sometimes, despite of applying the lenses, there is slow movement. Now, what does it suggest? Slow movement means you have to increase the power of the lens. Suppose I have placed a lens of +2 diopter sphere and the movement of red reflex has slowed down. That means I am under correcting the patient and I have to increase the power of the lenses. So that means you have under corrected the refractive error. And sometimes what happens is you start getting the opposite movement. The reflex which was initially with the movement, now after applying a lens, the movement of the red reflex is in the opposite direction. What does that signify? That signify that you have over corrected the refractive error. Okay. Another important point about the reflex is this: if you have to look at the characteristics of the reflex. So if your reflex is TDS, okay, see, TDS is a mnemonic. If you see in layman terms, it refers to tax deduction from the source. So people who have a high income, they only mainly have a lot of, they have to pay a lot of TDS, right? Similarly, if you look in the eye, the catch to learn here is patients who have high amount of refractive error, they will have these types of characteristic in the red reflex. Now, what does TDS stand for? A thin reflex, or a dull reflex, or a slow reflex. Okay. On the other hand, if the reflex is thick, if the reflex is bright, or if the reflex is fast, that means the patient has lower refractive error. Right? I hope I am clear in this. Then one very important thing to note here is the concept of cycloplegic agents. Now, what are cycloplegic agents? They are the agents that decrease the tone of ciliary muscles, and along with that, they lead to dilation of the pupil. Now, why do we have to decrease the tone of ciliary muscles? See, what happens is in children, when we ask them to look onto the Snellen's chart, sometimes they try to accommodate. Okay, so this accommodation will induce the myopia and will give us false results. And this high accommodation even suppresses your latent hypermetropia. So by giving the cycloplegic agents, what we are doing is we are inducing the hypermetropia. Okay, so both latent and manifest hypermetropia, you will be able to calculate that, right? So cycloplegic agents are given most commonly in children. What are these cycloplegic agents now? They are number one, atropine. This is used for children less than 5 years. It is used as 1% eye ointment at night for 3 days. So, one very important MCQ question is, how long do these cycloplegic agents act? So, the duration of action of atropine is 10 to 20 days. For cyclopentolate, the duration of action is 6 to 18 hours. That is less than 1 day. And for hometropin, it is 48 to 72 hours. That is 2 to somewhere around 2 to 3 days. Okay, then there are drugs such as tropicamide and phenylephrine. So these drugs, help, they don't act on the accommodation. Okay, so they are not causing cycloplegia, they are instead causing only mydriasis, that is dilatation of the pupil. However, these three drugs, they are causing both cycloplegia along with your mydriasis. So if you look here, the effect of tropicamide and phenylephrine, it lasts just for 4 to 6 hours, not more than that. Okay, now we will see how do we calculate how do we prescribe the spectacles to the patient. So now we'll study about spectacle prescription. Before studying how to give the power of spectacles, we have to learn two things which are very important. So number one is you have to look at what distance was the retinoscopy performed. Okay, see, we know that the dioptric power is equal to 1 by focal length, where this focal length here refers to the distance between the examiner and the patient, right? So if we have done retinoscopy at 1 meter, that power will come out to be 1. So we have to subtract this distance from the retinoscopic findings. Suppose our distance was 2 by 3 meters. So we will have to subtract minus 1.5 diopter from the retinoscopic findings. Another thing which you need to know is whether any cycloplegic was used or not. So what we have to do is, when a cycloplegic is used, then we have to subtract the tonus allowance from the retinoscopic finding, which in case of atropine is minus 1 diopter, cyclopentolate is minus 0.75 diopters, and for homide it is minus 0.50 diopters, right? So now let us look at some examples on how to prescribe the classes. Suppose after doing retinoscopy, the findings here are +4 and +4. The retinoscopy was done under atropine and at a distance of 1 meters. So we subtract -1 for atropine and -1 for distance. So our final would be +2 and +2. Since the power in both the vertical and the horizontal media is same, that means we can prescribe a sphere that will act both equally, both on the horizontal and the vertical media. So what we'll prescribe is, we'll prescribe +2 diopter sphere. Okay. Another example here is -3 and -2. Again, this retinoscopy was done under atropine and done at a distance of 1 meter. So -3, -1, -1, -2, -1, -1. So now if we look, this is -5 and this is -4. Okay, I'll just write it down on next page. -5 and -4, right? So now what we'll do is, we'll give the sphere of lower power. Okay, so we'll give a sphere that will act at 360 degree, and so can we write it down as -4 diopter sphere? This -4 diopter sphere will take care of the horizontal meridian, and minus so this -4 diopter sphere will take care of the -4 diopter in the horizontal meridian, and for the vertical meridian also it will take care of -4 diopter. But -1 diopter will still be left. That means we will have to prescribe it only for the vertical meridian. Okay, so it will be prescribed as a cylinder. Since we know that sphere, it acts at 360 degree, and your cylinder acts along a particular axis, right? So can we write it as -1 diopter cylinder? Now looking at the axis, see, one very important thing you have to remember is cylinders act perpendicular to the plane they are prescribed. That means if you are giving a cylinder at the vertical meridian, it will act on the horizontal meridian. Similarly, for a cylinder in the horizontal meridian, if you have given it horizontal meridian, it will act at the vertical meridian. Okay, so for this -1 diopter cylinder to act at the vertical meridian, I will have to prescribe it at 180 degree. So that when I prescribe it at 180 degree, it will act at 90 degree, right? Again, we'll look at it via one more example. So minus, we'll take it as +4 and +2. Okay, so this was done at a distance of 1 meter, and there was no cycloplegic that was used. Okay, so we just have to subtract 1 for the distance, and since no cycloplegic was used, we don't have to subtract anything. So our par cross will be +3 and +1, right? So we can give +1 diopter sphere. It will take care of +1 even in the vertical meridian and complete +1 in the horizontal meridian. So +2 will be left in the vertical meridian. So we can give +2 diopter cylinder at 180 degree. That will take care of the +2 diopter sphere at 90 degree. So I hope you have understood this. See, if we look at these glasses, so in these glasses, the power of cylinder is more than that of sphere, right? Since the power of cylinder is more, so we all know that having a high cylindrical power is a bit uncomfortable for the patient, right? So what we can do is we can transpose this. Now, how do we do transposition? So there are certain steps of transposition. See, you can either be asked, you can have a question directly in your exam in which they have given you a spectacle power, and they will ask you to transpose that power. Okay, so now look carefully. Number one is you have to add the spherical and the cylindrical power. Number two, you have to change the sign of cylindrical power, and simultaneously the axis of cylinder by 90 degree, right? So if we look at this, +1 diopter sphere and +2 diopter cylinder at 180 degree. So if we add both the parts, it will come out to be +3 diopter sphere, and you have to change the sign of the cylinder. So it will come out to be -2 diopter cylinder, and change the axis by 90 degree. So it will be -2 diopter cylinder at 90 degree. Okay. Another example, -3 diopter sphere, -2 diopter cylinder at 90 degree. So you have to add both of these, so it will come out to be minus 5 diopter square. And then you have to change the sign of the cylinder and the axis by 180 degrees. Sometimes in question they may even ask you about the concept of spherical equivalent. They will give you an equation like this, or say this, and they will ask you what is the spherical equivalent of this spectacle prescription. So spherical equivalent is the spherical power plus half of the cylindrical power. So spherical power would be 3 diopter square plus half of minus 2 diopter square. So it will come out to be 3 diopter square minus 1 diopter square, right? We don't have to ignore the signs. Okay, so that will come out to be 2 diopter square. So this will be the spherical equivalent of this equation. So this was all about retinoscopy. I hope I have cleared you about the power cross, the transposition and spherical equivalent, and the duration of action and other small things about retinoscopy. Thank you.